Now that we've simplified, now that we've combined, we have to now solve rational equations. So, for example, what you'll run into is something like 1/5 equals 4/5 plus 1 over x. So the real rational expression part is over here. The idea is always going to be the same. Find the common denominator, and then you can solve the rational equation. In this case, these denominators have a 5, and the last one is missing it, so I'm going to be multiplying by 5 over 5. But this guy has an x, and these guys are missing x's, so I'm going to multiply by x over x and x over x. So let's rewrite this. This would be x all over 5x. This would be 4x all over 5x plus 5 over 5x. And now, you're going to do something that will get rid of the denominators. You could just multiply everything by 5x. What we're left with then is x equals 4x plus 5, because 5x will cancel with all of them. Another way to think of it, 1 over 2 plus x over 2 equals 7 over 2. Say you had that rational expression. Well, you don't really have to think about the 2's at all, right? What you're really doing is thinking 1 plus what will give you 7. So the answer is 6. It's the same thing here. Once you get a common denominator, you can actually disregard all the denominators. Alright, now that we're here, I'm going to subtract 4x from both sides and get x alone by dividing. So it'll be negative 5/3. Okay, here's another one. Now you're going to encounter some expressions where you don't have a denominator, like here with the 4. It actually does have one, you can just put it over 1. Now, this has an x. The other two need an x, so I'm going to multiply this by x over x, and this one by x over x. Likewise, this one has an x plus 3, but the other two don't, so I'm going to multiply this by an x plus 3, all over x plus 3. And over here, this guy also needs an x plus 3 all over x plus 3. Now, if you look at all the basements, all the denominators have x times x plus 3. So I'm going to work on rewriting this all the tops in a more neater, in a neater way. So this is just going to be x plus 3. This is just going to be x, and this is going to be 4x times x and 3. So this is going to be 4x squared plus 12x. Now, I wrote out all the tops, and I could actually just go with this because remember, when we find common denominators, we could get rid of them. And now we're just solving the tops here. But let me write it out just to be clear here. Okay, and now we're going to disregard the bottoms, kind of like multiplying by x times x plus 3 all the way through. So x plus 3 plus x, that would be 2x plus 3. And we have 4x squared plus 12x. Alright, I'm going to subtract everything to the other side. Now if I take away 2x on both sides, I get 10x. And then I have, this is going to be a minus 3. Now for this example, we're not going to be having a nice factoring or a nice solving. This is just going to be using the quadratic equation. So we'll have negative 10 plus or minus the square root of b squared minus 4 times a times c all over 2a, which is 8. Now in the radical here, 4 times negative 3, 16 times 3 is 48, so this would be negative 10 plus or minus. And because it's a minus minus, this would be 148 underneath the radical. Work that out on my calculator, I get 0.271. And I also get negative 2.771. So, not the prettiest answers, but there we have it. So, I have one for you to try now. So try this out. Alright, you should pause the video and give it a try. Alright, first thing to notice, this is 10 all over x times x minus 2. And this x times x minus 2 is what we want for our denominator. Because this guy already has an x, this will be multiplied by x. And since this guy already has an x minus 2, we're going to multiply this one by x minus 2. And so I'll write it out here. Plus 4 times x minus 2 equals 5x all over x times x minus 2. Okay, now we have all the same denominator, so we can ignore that and focus on solving the numerators. Now I did two things here. I did distribution, and then I'm going to be combining like terms, so 10 minus 8 is 2. If I subtract 4x on both sides, I get x equals 2. Okay, very good. Now, there is one thing that you need to know about this. There is something called extraneous solutions. X equals 2 would be a perfectly fine answer. But at the end of every one of these, you have to go back and make sure that you're not getting an answer that's not in the domain of the expressions. So going back up here, you notice right here, if I put x in here, it would be 5 all over 0. 2 minus 2 is 0. So there are some times where you get an answer like this. You go back to the original equation, and then you say, oh, well, if I actually put this in, I'm actually going to get an undefined term. And if one part of this breaks down, the whole thing breaks down. This is called an extraneous solutions. So sometimes you're solving, you get like 2 answers, and actually one of them turns out to be extraneous, so you only have really one answer in the end. Sometimes you don't have any answers. And because this is extraneous, we would just say, well, this equation has no answers. All the answers we found, well, they're extraneous.